first problem solving class of time response analysis. Here the first question is the closed loop transfer function of a system is Ts equal to 4 divided by s square plus 0.4s plus 4. The steady state error due to unit step input is. This question has been asked in GATE 2014 S2. So let us see what will be its solution. It's a fill in the blank type question. So the transfer function given is Ts equal to 4 divided by s square plus 0.4 s plus 4. And this is the closed loop transfer function. The closed loop transfer function of a system. What is it? It is a closed loop transfer function. The steady state error due to a step input. The question is asking about the steady state error due to a step input. So the input is a step input. Input RT is a step input. So it is given that a steady state error due to a step input. Now what is Ts? Now Ts is nothing but it is a Laplace transform of output is to Laplace transform of input. So if we denote output by Ct, then the Laplace transform of output will be Cs. Cs divided by Rs. Rs is the input, is equal to 4 divided by s square plus 0.4 s plus 4. Now Cs is equal to, now Cs will be nothing but 4 multiplied by Rs divided by s square plus 0.4 s plus 4. Okay. Now what is Rs? Since it is unit step input, so Rs will be 1 by s, because the Laplace transform of a step input is 1 by s. So it will be 4 by s, 4 divided by s divided by s square plus 0.4 s plus 4. Okay. Now what will be the final value of output? Means what will be the steady state value of output? So a steady state value of output is equal to C infinity, or you can say limit Ct when t tends to infinite. Now here we have to apply the final value theorem of due to Laplace. So if we apply the final value theorem, so it will be nothing but limit s tends to 0 scs. So we can write here by final value theorem of Laplace, by final value theorem of Laplace. So now here we are applying the final value theorem of due to Laplace. So it will be equal to, this will be nothing but limit s tends to 0. What is Cs? Cs is here. So s multiplied by Cs is nothing but 4 by s divided by s square plus 0.4 s plus 4. Now this s will cancel out this s. Now if we put s equal to 0, then it will be nothing but 4 divided by 4. So it will be 1. Now a steady state error. A steady state error will be nothing but RT, or you can say R infinite, means the value of input at t equal to infinity minus C infinity. The value of output at c equal to the value of output at t equal to infinity. So since input is unit step input, so its value will always be equal to 1. But and out the value of output at t equal to infinity is also 1. So error will be 0. So here the value should be 0. The second question is the steady state error of a unity feedback step input is 0.1. The steady state error of the same system for a pulse input RT having a magnitude of 10 and a duration of 1 second is as shown in figure is. So this question has been asked in GATE 2011 and there are 4 alternatives given. So which one of the 4 alternatives is correct one? So a steady state error of his unity feedback system, unity feedback step input is means a system is given and the steady state error due to unit step input is 0.1. Again the system is unity feedback system, here unity feedback, and the input is unit step input. So as we know, the steady state error is given by ESS, a steady state error. Let me write a steady state error. So a steady state error, is given by ESS equal to SR limit S tends to 0 SRS divided by 1 plus GS. Okay, where GS is the process and RS is the input. Where GS is the process, this RS is input, and this GS is process. Okay, now if we give unit step input, then the error will be case 1 for unit step input ESS, let me write it by ESS 1. This will be equal to limit S tends to 0 S multiplied by, what will be the Laplace transform of unit step input? It will be 1 by S. So 1 by S divided by 1 plus GS. So S will cancel out each other. So it will be 1 by or you can say 1 by 1 plus G0, because if we put the value of S as 0, then it will become G0. So this value is given as, this is given as 0.1. So now that is, we can write 1 plus 1 by G0, this is equal to 0.1. So let me denote it by equation number 1. Now case 2. When we give the pulse input as denoted in the figure, for pulse input as denoted in the figure. So what will be the formula for this pulse input? So formula for this pulse input will be RT equal to nothing but the amplitude is 10 and its duration is 1 second. So it will be 10 multiplied by ut minus ut minus 1, where ut is the unit step function and ut minus 1 is also a unit step function, but it is delayed by 1 second. So this is a unit step function, a delayed unit step function by 1 second. Now what will be its Laplace transform? So its Laplace transform Rs will be 10 multiplied by 1 by s minus e to the power minus s divided by s, because here t minus 1 is coming, so for minus 1 it will be e to the power minus s. Now the steady state error, so let me write a steady state error as ESS2 due to this as the pulse input. So steady state error will be limit s tends to 0 s multiplied by Rs divided by 1 plus Gs. Now what is Rs? Rs is s multiplied by, if we take 1 by s as common, let me write here because here we don't have more space. Limit s tends to 0 s multiplied by, if we take 1 by s as common, so it will be 10 by s 1 minus e to the power minus s, okay, divided by 1 plus Gs. Now s will cancel out each other. Now if we put the value of s as 0, then what will happen? Then this term will be e to the power 0. If this term will be e to the power 0, so anything to the power 0 is 1. So now we can write here 10 into 1 minus 1 divided by 1 plus G0. 1 plus G0. So it will be 0 only, because the numerator is 0. So how much error will be due to this pulse input? So error will be 0. So which option is correct? So option number A is correct one. The next question is, for the system 2 divided by s plus 1, the approximate time taken for a step response to reach 98% of its final value is. There are 4 alternatives given, and this question has been asked in GATE 2010. So the transfer function of the system is given, and the input is also given. It is a step response. So input is a step input. So two things are given, a step response and transfer function. So transfer function Ts is given as, so transfer function Ts, it is given as Ts equal to 2 divided by s plus 1. Now Ts is nothing but it is Cs by Rs equal to 2 divided by s plus 1. Now what is input? Rs is a stepless input. So Cs will be equal to 2 divided by s plus 1 into Rs, and in place of Rs we can write 1 by s, since the Laplace transform of unit step is 1 by s. So 2 divided by s into s plus 1. This s comes for Rs. Now if we take the partial fraction, then it will come a by s plus b by s plus 1. Now we have to calculate a and b. So a will be calculated by a equal to s multiplied by cs at s equal to 0, since the pole is at 0. So what will be it? S multiplied by 2 into s in 2 divided by s into s plus 1 at s equal to 0. Now s will cancel out each other. Now it will be 2, and b will be equal to s plus 1 multiplied by cs at s equal to minus 1. So it will be s plus 1 multiplied by 2 divided by s into s plus 1 at s equal to minus 1. Since here the pole is at s equal to minus 1, so s plus 1 will cancel out each other, and it will come minus 2. Now finally CS, we got CS equal to, now we get CS equal to, from here CS equal to 2 by S minus 2 by S plus 1. Now if we take the inverse Laplace transform of this both the side, then we will get Ct equal to, taking inverse Laplace transform, inverse Laplace transform, we get Ct equal to 2 ut minus 2 into, since S it is 2 divided by S plus 1, so e to the power minus t will come here, e to the power minus t ut. Now if we take ut as common, then 2 minus 2 e to the power minus t ut. Okay. Now the question is asking about the time taken by the response, this response, to reach the 98% of its final value. So what is its final value? So final value, the response will reach the final value at t equal to infinity. So we can write final value of Ct is Ct at t equal to infinity. So what will be the final value? 2 minus 2 e to the power minus infinity ut, and that will be nothing but this will be 0, so it will be 2. Now what is 98% of this final value? Let the system takes time t dash to reach 98% of its final value. So let us write, let the response reaches 98% of its final value at t equal to t dash. Now let me write this side. So now we can say that Ct dash is nothing but 0.98 multiplied by C infinity. So how much it will be? 0.98 multiplied by, what is C infinity? C infinity is 2 unit. So it will be 1.96. Now what will be Ct dash? So Ct dash will be 2 minus 2 e to the power minus t dash. Here it is written 2 minus 2 e to the power minus t dash, and it will be equal to 1.96. So 2 e to the power minus t dash, if we take 2 e to the power minus t dash in right side of equal to, and if we take 1.96 in left side, then it will be 2 minus 1.96, and that will be equal to 0.04. Now e to the power minus t dash is equal to 0.02. Now if we take the natural log of both the sides, then it will come t dash equal to ln 0.02. So if we take the natural logarithm of this 0.02, then it will come minus 4, around minus 4. So t dash will be equal to nothing but 4 seconds. So which option is correct? So option number C is correct. The next question is, a function yt satisfies the following differential equation: dyt by dt plus yt equal to delta t, where delta t is the delta function. Assuming zero initial condition and denoting the unit step function by ut, yt can be of the form So the differential equation is given. So what is the differential equation? Dyt by dt plus yt, this equal to delta t. Also it is given that assuming zero initial condition, means initial condition is 0. So now if we take the Laplace transform of both the side, then no term with zero initial condition will come. So now taking Laplace transform of both the sides, we get, how much we get? S by s, where ys is the Laplace transform of yt, plus ys, this will be equal to 1 because the Laplace transform of delta function is 1. Now if we take ys as common, so it will come s plus 1 equal to 1. Now ys will be equal to nothing but 1 by s plus 1. So now we have got the ys. Now, and denoting the unit step function by ut, yt can be of the form. So the question is asking about yt. So now if we take the inverse Laplace transform of both the sides, then taking inverse Laplace transform of both the sides, yt will be equal to, how much it will be? Yt will be equal to e to the power minus t ut, because here a term here plus 1 is associated with s. So if it would have been 1 by s only, then the inverse Laplace transform would be ut. But since plus 1 is associated with s, so it will be e to the power minus t ut. So which should be the correct answer? So the correct answer is answer number D, e to the power minus t ut. Is equal to 5 divided by s into s square plus 3s plus 2, where fs is the Laplace transform of the function ft. The initial value of ft is equal to. So the question is asking about what is the initial value of ft. What do you mean by initial value? Initial value means the value of function at t equal to 0. So the initial value of ft, the initial value of ft is given by f0 equal to limit t tends to 0 ft equal to limit s tends to infinity sfs, and this is by Laplace initial value theorem. Now here we have applied Laplace initial value theorem. So it will be equal to limit s tends to infinity. What is fs? Fs is given here. So s multiplied by fs is nothing but 5 divided by s into s square plus 3s plus 2. Now s will cancel out each other, and if we put s equal to infinite, then the value will be 5 by infinite. So it will be 0. So which option is correct one? So option number D is correct one. System is defined by the following mathematical relationship: d2x by dt square plus 6dx by dt plus 5x equal to 12 multiplied by 1 minus e to the power minus 2t. The response of the system as t tends to infinity is. There are 4 alternatives given, and this question has been asked in GATE 2003. Now the mathematical relationship is d2x by dt square plus 6 dx by dt plus 5x equal to 12 1 minus e to the power minus 2t. So this mathematical relation is given for the system. The response of the system as t tends to infinity. Now the question is asking about the response of the system when t tends to infinity. So let us find the transfer function of the system. So what will be the transfer function of this system? So the transfer function of the system will be calculated after taking all initial conditions 0. So taking Laplace transform of both the sides, assuming all initial conditions 0. So taking Laplace transform of both the sides, assuming all the initial conditions 0. So what will happen here? For d2x by dt square, the Laplace transform will be s square xx, where xx is the Laplace transform of this small x, plus 6s xs plus 5xs, and here 12. The Laplace transform of 1 will be 1 by s, and the Laplace transform of e to the power minus 2t will be 1 by s plus 2. 1 by s plus 2. Okay. Now if we take xs as common, so this will come s square plus 6s plus 5xs. This is equal to 12, and here s into s plus 2, here s plus 2 minus s. So s will cancel out each other. So it will be 24 by s into s plus 2. Okay. Now xs will be nothing but 24 by s into s plus 2 divided by s square plus 6s plus 5. Now the question is asking about the response of the system as t tends to infinity. So now we have to apply the final value theorem due to Laplace. So the response of the system at t equal to infinity, the response of the system at t equal to infinity, is given by x infinite, or you can say x infinite. This will be equal to limit t tends to infinity xt, and in form of Laplace transform it will be limit x tends to 0 s xs. So it will be limit s tends to 0 s, and what is xs? 24 divided by s into s plus 2 multiplied by s square plus 6s plus 5. Now s will cancel out each other, and if we put s equal to 0, then the numerator will be 24 and denominator will be 2 multiplied by 5. 2 multiplied by 5. So it will come 10. So 24 divided by 10, and it will finally come 2.4. So which option is correct? So option number C is the correct one. Now at the last of the lecture, I would like to share one of the most important thing to you people, that if you like my video, then you must subscribe my video, so that there is no need to search out new video. Automatic update will come if I upload the new videos. What you have to do, it is very simple. There is a circular logo coming in right of me. You have to just click on that to subscribe.